Our solar system is a place of wonder, filled with celestial objects that spark our curiosity. From the blazing sun at its center to the icy bodies at its fringes, each component tells a unique story. Among these celestial wonders is Uranus, a giant icy world that holds the title of the coldest planet in our solar system. Its frigid nature and distant orbit make it a fascinating subject of study. Unlike the rocky planets closer to the Sun, Uranus is classified as a gas giant. It is composed primarily of hydrogen, helium, and methane, which give it a distinct composition and appearance. This unique composition contributes to its frigid temperatures, but it's not the only factor at play. The planet's distance from the Sun and its internal dynamics also play crucial roles in its icy demeanor. Uranus's story begins in 1781 when astronomer William Herschel stumbled upon it while surveying the night sky. Using a homemade telescope, Herschel made a discovery that would change our understanding of the cosmos. At first, Herschel thought he had discovered a comet, but further observations revealed its true nature as a planet. This was a groundbreaking moment in the history of astronomy. This discovery expanded our understanding of the solar system, adding a seventh planet to our cosmic neighborhood. It was a significant addition that reshaped our view of the solar system's structure. Uranus, named after the Greek god of the sky, quickly became an object of fascination for astronomers. Its unique characteristics and distant orbit made it a subject of intense study and curiosity. Its blue-green hue, a result of methane in its atmosphere, hinted at a world unlike any other. This coloration set Uranus apart from the other planets and added to its mysterious allure. But as scientists delved deeper into its characteristics, they uncovered a chilling truth. Uranus was the coldest planet in our solar system, even colder than its neighbor Neptune, which orbits farther from the Sun. This discovery was both surprising and intriguing. This discovery raised a perplexing question. How could a planet farther from the Sun be warmer than one closer? The answer to this question required a deeper understanding of planetary science and the unique conditions on Uranus. The answer lies in a complex interplay of factors including internal heat, axial tilt, atmospheric composition, and even the possibility of a cataclysmic event in its distant past. These elements combine to create the extreme conditions observed on Uranus today. As we continue to study Uranus, each new discovery adds to our understanding of this distant world. Future space missions and advanced telescopes promise to reveal even more about its mysteries, helping us piece together the story of this enigmatic planet. The journey of discovering Uranus is a testament to human curiosity and the relentless pursuit of knowledge. It reminds us that the universe is full of surprises, waiting to be uncovered by those who dare to look beyond the familiar. At first glance, it seems counterintuitive that Uranus, the seventh planet from the Sun, would be colder than Neptune, the eighth. This is especially surprising given the general rule that the farther a planet is from the Sun, the less solar radiation it receives, and thus, the colder it should be. After all, the farther a planet is from the Sun, the less solar radiation it receives. This principle is a fundamental aspect of planetary science and is observed in most planets within our solar system. This principle holds true for most planets in our solar system, but Uranus breaks the mold. Its unique characteristics set it apart from the other planets, making it an intriguing subject of study. The average temperature of Uranus hovers around -371 degrees Fahrenheit, making it the coldest planet in our solar system. In comparison, Neptune's average temperature is a comparatively balmy -353 degrees Fahrenheit. This difference in temperature is quite significant given that Neptune is farther from the Sun. This discrepancy in temperature, despite Uranus being closer to the Sun, has puzzled scientists for decades. It challenges our understanding of planetary climates and the factors that influence them. It suggests that factors other than solar radiation play a significant role in determining Uranus's frigid climate. These factors include the planet's internal heat, atmospheric composition, and possibly even its magnetic field. One of the most critical factors is the planet's internal heat, or rather, the lack thereof. Internal heat is generated by processes such as radioactive decay and residual heat from the planet's formation. Unlike Earth, which generates heat from its core through radioactive decay, Uranus emits very little internal heat into space. This lack of internal heat is a significant factor in its extremely low temperatures. This lack of internal heat is a defining characteristic of Uranus and contributes significantly to its status as the coldest planet. It is a stark contrast to other gas giants in our solar system. While other gas giants like Jupiter and Saturn radiate more heat than they receive from the Sun, Uranus remains remarkably cold, radiating minimal heat from its interior. This makes Uranus an outlier among the gas giants. The reasons for Uranus's lack of internal heat are still being investigated, but several theories attempt to explain this anomaly. Understanding these reasons could provide insights into the planet's formation and evolution. One theory suggests that Uranus may have experienced a massive collision early in its history, disrupting its internal heat flow. Such a collision could have caused significant changes in the planet's structure and thermal properties. Another theory posits that Uranus's unusual axial tilt might play a role in inhibiting heat convection within the planet. This tilt, which is about 98 degrees, is unique among the planets in our solar system, and could affect how heat is distributed within Uranus. Additionally, the composition and dynamics of Uranus's atmosphere may also contribute to its cold temperatures. The atmosphere is composed mainly of hydrogen and helium, with trace amounts of methane, which gives the planet its blue color. Methane in the atmosphere absorbs red light and reflects blue light, but it also plays a role in the planet's thermal dynamics. The presence of methane could influence how heat is trapped or radiated away from the planet. Future missions to Uranus may provide more data to help unravel these mysteries. By studying Uranus up close, scientists hope to gain a better understanding of its unique characteristics and the factors that make it the coldest planet in our solar system. Imagine a planet that's not so much a world of fire and ice, but rather a world of ice and colder ice. That's Uranus in a nutshell. The planet's core, while likely composed of rock and ice, doesn't generate the same level of intense heat found in other gas giants. This lack of internal heat is a key reason why Uranus holds the title of the coldest planet. Think of it like this. Earth is like a freshly baked potato, still radiating heat from its core long after it's been pulled from the oven. Uranus, on the other hand, is like a potato that's been sitting in the fridge for days, cold to the touch with little to no internal warmth. This lack of internal heat affects Uranus's atmosphere, preventing it from generating significant heat from within. While other gas giants have turbulent atmospheres with massive storms fueled by internal heat, Uranus's atmosphere is relatively calm and frigid. The planet's icy heart simply doesn't provide the energy needed to drive powerful atmospheric circulation patterns or generate significant internal heat. The reasons for Uranus's lack of internal heat remain a mystery. Some scientists speculate that it could be related to the planet's formation or a massive collision that disrupted its internal structure. Regardless of the cause, this lack of internal heat is a defining characteristic of Uranus, contributing significantly to its extreme cold. Section 4. Tilted Axis, a world on its side. Uranus is a planet of many peculiarities, but perhaps its most striking feature is its extreme axial tilt. Unlike Earth, which spins on its axis at a tilt of 23.5 degrees, Uranus is tilted on its side at an angle of 98 degrees. This means that Uranus essentially rotates on its side, with its poles pointing almost directly at the Sun for part of its orbit. This unusual tilt has profound implications for Uranus's climate. While Earth experiences distinct seasons due to its tilt, Uranus's seasons are extreme and drawn out. For about a quarter of its 84-year orbit, one pole of Uranus faces the Sun continuously, while the other pole remains shrouded in darkness. This extreme tilt means that Uranus receives solar energy unevenly, with one hemisphere bathed in sunlight for decades while the other experiences a prolonged winter. This uneven heating could contribute to Uranus's overall coldness, as the planet has limited time to warm up even when one hemisphere faces the Sun. The cause of Uranus's extreme tilt is still debated, but the leading theory suggests that it resulted from a collision with a massive object early in the solar system's history. This impact, billions of years ago, could have knocked Uranus on its side, leaving it with its distinctive tilt and influencing its climate ever since. Section 5. Distant Sun, a weak embrace. Distance plays a crucial role in determining a planet's temperature. The vastness of space means that even small differences in distance can lead to significant changes in the amount of solar energy a planet receives. The farther a planet is from the Sun, the less solar radiation it receives and the colder it tends to be. This is a fundamental principle of our solar system's dynamics. Uranus, orbiting the Sun at an average distance of 1.8 billion miles, receives significantly less solar energy than Earth. This immense distance places Uranus in a region of space where the Sun's warmth is but a faint whisper. Imagine standing near a bonfire on a chilly night. The fire's warmth is comforting and immediate. The closer you are to the fire, the warmer you feel. The heat is intense and enveloping, providing a shield against the cold. As you move farther away, the heat diminishes and the air grows colder. The warmth fades, and the chill of the night becomes more pronounced. The same principle applies to planets and the sun. The distance from the sun dictates the amount of solar energy a planet receives, influencing its climate and temperature. Earth, basking in the sun's warmth at a comfortable distance, enjoys a temperate climate. This proximity allows Earth to sustain life, with temperatures that are neither too hot nor too cold. Uranus, however, circles the sun from a frigid expanse, receiving only a fraction of the solar energy that reaches Earth. This distant orbit places Uranus in a perpetual state of cold. This vast distance means that the sun, while still the brightest object in Uranus's sky, appears much smaller and dimmer than it does from Earth. The sun's light is weak and spread thin across the vast distance. The solar energy that does reach Uranus is spread out over a much larger area due to the planet's size, further reducing its warming effect. This dispersion of energy means that even the sunlight that does arrive is less effective at heating the planet. While Uranus's distance from the sun isn't the sole reason for its extreme cold, it's a significant contributing factor. The planet's position in the solar system places it in a zone where solar energy is scarce. The combination of its distance, lack of internal heat, and extreme axial tilt creates a perfect storm for frigid temperatures, making Uranus the coldest planet in our solar system. This unique set of conditions ensures that Uranus remains an icy world, far removed from the warmth of the sun.